Hey guys, so today we're doing a cool problem and we're trying to find the frequency of strings occurring in a list of strings. So that's normally a fairly straightforward problem, but we're putting a little twist on it and we're going to say that we need to get the kth largest or kth most frequent element in a list of strings. So it's a little bit trickier because we can't just calculate the frequency for all of the strings and then get the most frequent one. We have to actually figure out what the kth most frequent one is. So it's going to be a cool little problem. Let's just dive right in. The first thing we have to do is, I have a couple questions. The first of which is, what happens if k is greater than the number of unique words? Right? Because if we have like I am Sam, for example, and those are our three words, and then k equals 4, then this makes no sense, right? Because k is going to be beyond the end of all of our words, so there is no kth. There is no fourth most frequent word. So we just want to ask our interviewer how to handle this. In this case, we're going to be returning a string, so let's just say if it's out of bounds, we're just going to return null. So that's fairly straightforward. We also want to ask, what do we do if there are two words that are occurring at the same frequency? So in that same set of words, again, all of these words occur one time. So so do we want to count all of these as the first most frequent and the first least frequent word, or are we just going to order them arbitrarily, or are we going to sort them within that ordering? So it's like am I Sam, because it would maybe be an alphabetical order within all of the words of the same frequency. In this case, doing all of those things is going to complicate the problem a bit, so we're just going to say that we're going to just take if there are multiple words that are the same frequency, we're just going to take any word of that frequency. And that'll just simplify it a little bit, and we're not going to have to worry about it as much. Although you can certainly think about on your own maybe, or discuss in the comments, we can talk about how you could solve it that way, so that you would actually, maybe return all of the words that are a certain frequency. So if k is 2 and you have one word that occurs 5 times and 3 words that occur 4 times, then you would return all 3 of those words. So, but in this case, we'll say we're just going to return an arbitrary word of a given frequency. So in this case, if you have 1, 2, or 3, it's just going to return one of these words, and that's fine. Or 0, 1, and 2, I should say, for k. And then the last question I have is, how exactly is this code going to be used? Because we can imagine we're going to be doing some sort of pre-processing of our input and putting it together into some sort of structure that we can access the kth element easily. But maybe what we would imagine doing would be creating an object for this. So you'd construct an object, do all the pre-processing, and then you would actually just call get element at k over and over again, and that might affect how you would actually implement this, because then you would want to maybe spend more time pre-processing but create a data structure where it's a constant time access. So you maybe would want to have like an array of values at the end that you would store, and then you can keep calling into that and it will take constant time, so it might be more efficient depending. And that's something you could talk about with your interviewer, and it might be cool to show them that you're thinking about this. But we're going to say for now we're just going to do this as its own. We're going to have one function that's going to take in an array of strings and a integer k, and we're not going to worry about creating a whole object around this. So let's dive in and think about how we're actually going to solve this problem. And I spent a little while thinking about this because there are a bunch of different ways that we could approach this problem, and they're all sort of similar, but any of these is a good solution. So if you came up with any of these solutions, that's awesome. And there are also other solutions, and we're going to look at a n log n solution, a big O of n log n solution, but you can actually solve this in linear time. And I'm going to include a link to how to do that in the blog post, but it's a bit more complicated, and you wouldn't really be expected to do that in an interview, so we're not going to worry about that here. But there are a couple ways we could solve this. The first way would be to use a hash map. So we can use a hash map, and then what we're going to do is we're going to first use the hash map to calculate the frequencies of all the words. We're going to put the word in, we're going to map the string to the frequency, and we're going to go through our list and we're going to add all the strings and then increment the frequencies so that we have the frequency, and then we're going to sort by the, so hash map and sort. So then we're going to sort this by the frequency and then get our value. So that's a pretty good solution. It's going to be an n log n solution because it's linear time to calculate all the frequencies, and then of n log n. And it's going to be linear time to calculate the frequencies, and then sorting is n log n if we use like a merge sort or a quick sort. So that's going to, and then the accessing after that is going to be constant time because we're going to end up with some sort of sorted array or an array list or something like that, which has constant time access. So that's one option, and I think that's a pretty good option. And the big downside of this option is that we have to implement a custom comparator, which means in Java, and this is different in different languages, so if you're not super familiar with Java, this might be a little bit confusing, but just bear with me. What we want to do is we have a hash map, and our hash map is a hash map of strings to integers, right? And by having the string to integer, if you sort it, you're normally going to sort by string, which is the first value. But in this case, we're going to want to sort by the integer value. And this is just going to make things a little bit more confusing when we actually do the sort. But it's going to not be super complicated. So that's definitely a good option. Another option that we could do is to use a hash tree. And a hash tree, in case you don't know, is just a sorted hash table in Java. So it stores, it's basically a binary tree type structure, but you use hashes of the values. So this would work by, we would add the items one at a time and it would sort them within the tree. And that we could do, and that would be a good solution as well. And that would also be n log n, because each addition, it's sort of like a heap, right? Where you're sorting it every time, you're sorting it every time you add an element. So it's going to readjust, and that takes up to log n. And then we're doing it n times because we have to go through all of our strings. So that's going to take n log n as well. So that's another option. And then another option is that we can map the frequencies to a list of strings. And what I'm talking about here is we would have a hash map of integer string, and then we would also have a hash map of string to integer. And what this would do is we would have we basically are doing the mapping in both directions. So we would store the hash map of the frequency to all of the strings that have that frequency, and then we would have a hash map of the string to the frequency. So what you would do when you were adding a string is you would look it up in the hash map of strings to integers. So you would look up the string and find the frequency, and then you would use the other hash map. You would look up then that integer in this other hash map and find the list of strings. Sorry, this should be a list of strings. So it would be like that. And then you would add the string to that list and remove it from the old list. So the advantage of this is that, remember we were talking in the beginning about how maybe you would want to return all of the strings of a given frequency. By doing this, you're grouping them together by frequency. So depending on how you're implementing this or how your interviewers asked you to do it, that may be a good solution. I don't love this solution as much given the context of what we're doing here, because it's a little more complicated when you want to find the kth element, because you have to go through frequency by frequency and you have to count the number at each frequency and make sure that your lookup could be up to n long. So it's not ideal in that respect, but given this, like in certain circumstances, this may be the best option for you. And one more option that we could do is that we could do a hash, basically this first option, but instead of sorting, we could take our hash map and use another method to find the kth element without actually sorting the list. And that may be more efficient. There are, I believe, solutions that you can do that more quickly, but that again is getting into more complicated algorithms and not really something you'd be expected to do in the interview. So I'm just going to gloss over those, but that is certainly an option. And so this is the sort of discussion that you may actually want to have with your interviewer, and it's totally reasonable. What I've basically done is I've gone through different solutions that I see and sort of laid out the pros and cons of each, because there are pros and cons of every one. And like all of these are potentially good solutions, but they may be better or worse for different reasons. So in this sort of problem, especially, this is a slightly more, it looks simple, the problem, but it ends up being a bit more complex. So it's really good to go through and just explain what you're thinking. And I'm just, sort of brain dumping all of the thoughts that I'm having about which ones are best and which ones, what are the pros and cons of each one. So in the end, I decided that I'm going to go with this first option, because I think it's going to be the simplest to implement, and it makes for fairly straightforward code, and it's going to be it's a good solution. So I'm going to go ahead and do that. But if any of those other solutions seem like they would make more sense to you, like those are totally acceptable solutions as well. So let's go ahead and I'm going to do a public string, and I'll call it most frequent, or we should probably just call it kth most frequent, because we are taking the kth most frequent element after all. And this could be, it could be an array or a list or a string. And then that makes it a little more complicated if we just take a string that's like a paragraph of text or something, because then you have to actually split it by character, and you can use just the split by space, but then you also need to strip out punctuation and stuff. So it gets a little more complicated. I'm not going to worry about that because this problem has enough going on already. And then we're going to take in an int k. And now, first of all, we need a hash map. And remember, so I'm making a hash map of strings to integers where I'm going to store the frequency, and then I'm going to convert that into a list, and I'm going to sort it. So I'm just going to call it map, and it's going to be a new hash map. And now I'm going to go through my list of strings, and I'm going to calculate the frequency for each one. So we're just going to do we're going to loop through all of the strings. So for string s in strings, and what we want to do is so there's a possibility that we haven't added the string to the hash map yet. So what I'm going to do is I'm just going to say, I'm going to get the value regardless. And if it's null, then I know that we haven't added it yet. So I'm going to add it as value being 1. And otherwise, I'm going to get the value, I'm going to increment it, and then add it back. So I'm going to use the integer object here, because I want it to be able to be set as null, which is a possibility in this case when I'm doing map.get. So I can't use the primitive type, because if I use the primitive type can't be null. So we'll get some weirdness there. So we're going to go ahead and then say if x equals null, then I'm just going to set it to be equal to 0. And I'm going to increment it regardless. So I'm just going to say map.put s, and we need to do plus plus x and not x plus plus in this case, because we want to increment it before we add it and not afterwards. So that's going to collate our list of frequencies, and that's all there is to that. And now I want to create a list, and what I'm going to do is there's an object called a map entry, And so a map entry has a key and it has a value because it's basically, it's one entry in a hash map. So, or any sort of map. So the advantage of using this is now we have both values that we need. So I can sort this list of key and of map entry objects, and I can create a custom comparator easily that's just going to compare the values of the two map entries. So if you don't know about map entries and stuff, and I didn't until I was researching it, that's not really a problem. Like, you can sort of talk to your interviewer about how you would do this, even if you don't know the exact syntax for how to do it, because this is a slightly syntactically more complex problem, especially if you haven't done a ton of Java. So it's not really a huge issue. It's better to just, as long as you have the logic there is the key thing. So we're gonna create an array list because we want something that's indexed, and entry set, and that's going to get our set of entries from the map, and then we're going to sort it. So we can use the collections dot sort. We're going to use list, and then we need a custom comparator because we're going to compare by the values and not by the keys. So to do that, we create a new comparator. You could also implement this as its own class, but we're just doing an anonymous subclass here, which is just, takes up less space, honestly. That's the main reason to do it. And we just have to implement compare, and it's going to take in two objects. Object O2. And now we want to compare them. So I'm gonna break this into a couple lines because I think it's cleaner. So value 1 is gonna be integer. There's a lot of weird casting here, so it's nice to break it into multiple lines because you really want your code to be as readable as possible. So you're just doing like get value, and then we do the same thing for the second object. So just call this v2 and o2. And now all we need to do is compare them. So we're just going to return, we're doing v1.compare to v2. And that's all there is to it. So that's like, if you know the syntax for it, it's really simple. If you don't, it's a little bit more complicated. But again, it's one of those things where you can sort of fudge it a little bit or ask for help from your interviewer, and it's not going to be the end of the world because everyone knows that you can look up how to do this online. And as long as you know that that is a thing that you can do, that's really the most important thing. And then last but not least, we have to actually get our value from this list. So now we have an assorted array list. And so we're going to say if list, so this also comes back to we have to make sure that k is in the range of our list, right? So we're just going to say if list.size is greater than k, then we know that k is within the range of the list. So we're going to return, we have to cast it to a string because that's not stored in the type. Get k, and we have to get the key because the list is a list of map entries, not of the actual strings. So as you can see, this is just going to get some arbitrary element that's at the k, that's the kth element, but it's going to get, there may be multiple different values there depending on if there are multiple items with the same frequency. It'll depend what value you actually get out, but that's fine. And then we're going to return null otherwise, and that's it. So we now need to test our code as we do always. So let's just come up with a simple example. We're going to say, because this could get very complicated very quickly, so I'm just going to say a simple array like A, B, C. Actually, I'm just going to do AAB, and that's probably going to take long enough, so that'll be fine. If you want to do a more in-depth test on your own, you're welcome to. And then we need to do something that's going to be in the range, so just 1. And now we're going to go through, and I'm going to, so we're going to have a map, right? And so we're going to come here, we're going to create our map, and now we're going through strings. So string S is this first one, A, and our map is currently empty. So integer X is going to be map.getS. So map.get A, and nothing's in the map right now, so that's going to be null. So we're going to say X is null, and so X is going to be set to equal 0. And now we're going to, in the map, we're going to put S, which is A, and plus plus X, which is 1. So we're going to put A maps to 1, right? So that should make sense. Then we're going to come back and do it again. We get A again. So this time when we do map.getS, we get 1. So it's not null. So we're going to put S, and we're going to put plus plus X, which is 2. So we're going to put A 2. And in the hash map, you can only have one of the same keys. So it's just going to replace the old value with the new value, which is exactly what we want in this case. And now our third string is going to be B. We're going to try and get it. It's going to be null. We'll set it to 0, and then we're going to put in B is 1. So now we have this is 1. And that's exactly what we expect, right? So we're going to come down to our list, or come down to this line, and we're going to create a list of map entries. So it's going to be a new list, which is the map entry set. So the map entry set is going to include these two, and I'm just going to switch this over here real sneakily. So now this is a list. Ta-da. And so now we need to sort our list. So we're going to come down here, we're going to compare them. We can just check that the comparator does what we expect it to do. So let's say we have these two objects and we compare them together. We're going to get object 1 is this A and 2, object 2 is the B and 1. So V1 is going to be object 1 dot get value, which is 2, which is what we expect, and V2 is going to be object 2 dot get value, which is 1. And so we're going to get 2 and 1, and then we're going to do 2 dot compare to 1, and that's what we expect. And you know, the collections sort, we're not going to worry about whether that works or not. We're just going to assume that that works, because it's basically a black box that does what we, as long as we create the right comparator, it's going to do what we expect it to do. So that's all well and good. And now we're going to come down to here, and we're going to say if list.size is greater than k. So list.size is 2 and k is 1, so it is greater than k. We're going to turn the string of list.getk.getKey. So list.get, so our list order now is going to be, I believe it sorts it greatest to, or largest to smallest. So it's going to be this order. And then we're going to get the first element, which is going to be the B, and we're going to get the key, which is B. And we want to return the string, right? So we're going to return the B, and that's all there is to it. And so it's a pretty small test. You can test it some more if you want to and have time, but you get the idea. And lastly, we want to, it's a little tricky, so we want to make sure that this is running in the time complexity that we expect. So we're going to create our map, that's fine. We go through all the strings once, so that is n, if n is the length of our list. So that takes n time, and then we create this new list, which is going to take n time to create the list. And then we're going to do this sort. And the sort is the one that's going to be the rate limiting step, or the one that's going to take the longest time. So the sort is going to be probably, I'm not actually sure how it's implemented in Java, but it's going to be either a quick sort or a merge sort. So we know that it's going to take n log n time, basically, because that's the fastest we can do on sorting. So we can just assume that's going to take n log n time. And then we have an array list here, so the lookup is going to be in constant time. So our slowest step was the sort, which is n log n. So that makes our runtime n log n. And we're pretty sure it works. And it's a slightly tricky problem, but hopefully that all made sense. And I will see you again soon.